Okay, start, set, go. Thank you for continuing to support the course with your attendance. And we need at least one, but better two labs before you can do two main activities in the course. Least important is share your skills in operating WASP, which will be done in less than 2 weeks. Right? And probably tomorrow it will be practice of democracy to select and elect which subject you want to present. And then the door will be open for projects. Please do not hesitate to contact me ahead of time about your projects and share some ideas. Some of you know what you will be doing, some of you maybe not. So it's better to plan a little ahead of time because the semester will end very soon. So today there are plans to cover two most, I don't know if they are most important, but really important practical things. Heating, molecular dynamics, and plotting orbitals. Plotting orbitals is what you already know and what looks familiar for you, and it will take substantially less time than molecular dynamics. It's about the same amount of intellectual effort, but computational effort for molecular dynamics is much more expensive. So you'll start from dynamics, submit some jobs, and then switch to orbitals. And then by the end of the class, some molecular dynamics data will be ready that we will visualize. So I'm going to share something. Oh, there is a stapler. This is so great. Steps for molecular dynamics, and I didn't include the steps for visualizing because we are changing from year to year as one gets more advanced software. So what I promise that you all will be able to visualize molecular dynamics on your screens, and if you have on the board the software, video from Lincoln on YouTube. Did you try to do the things? Huh? So do you have a video somewhere? I have. You have it on the laptop? No, not on this laptop. And you install it here on the laptop? I don't care, but you and I distributed it upside down. You need to start from the back. So you do have optimized journey of a model, and I suggest we will continue this titanium dioxide thing, lab 9-Wed. So why do you need, why we may need molecular dynamics? What's the benefit? Why do you do molecular dynamics for your project? Yes. What's the benefit?
Like I basically need trajectory analysis.
Huh?
I need trajectory analysis or like
Trajectory. Yeah, enough. Who else does molecular dynamics by now? Who did? Okay. Why do you do it? Okay, so because things are changing in time, right? The shape of a molecule or material changes in time. There are phase transition, like, I don't know, melting, freezing, phase transformations. Well, it's not only minimum, it gives you much wider range of effects. You can get chemical reactions upon breaking information. So what is molecular dynamics?
Analyzing the trajectory.
What is trajectory? Yes.
Like if you are giving a condition like a temperature and pressure, how the molecule has been moved from the initial state to the final.
How the molecule has been moved from initial state. So position of each ion is changing with time, right? So the same thing as we covered at the very beginning of the course for Newtonian equation of motion, right? So you do have force equals mass times acceleration. So if you are in the minimum, if you have potential energy surface and you have your positions of ions and you are already in the optimist minimum of the potential surface, do you have any molecular dynamics? Can you just start molecular dynamics from equilibrium geometry?
Can, but nothing's going to hold you.
Oh, yeah, he was the first. I need to focus camera on you because you did a good thing. Camera doesn't want to focus on you. Hey, camera. Focus on me. Yes. So, what will happen if you start molecular dynamics from equilibrium geometry?
Nothing will move.
Everyone agrees? Right? So if it is a little bit away from minimum to the left, force will push it back. If it is to the right, if it is a little to the left, force will push it back. And if it is in the middle, the force is zero. Yeah?
So this only takes into place like physics, not electrochemical interactions, like electronegativity, affinity towards each other.
It's all connected. You can launch some motion by applying potential. But let's start from like the basics. So what do you need to make ions to move? Huh? Well, you need to take a hammer and kick the molecule. That's correct. That's correct. On this diagram, what do you need to do? Like, if it sits in the minimum, it will not move, right? What do you need to do?
Give it some energy.
Yes, to move it away from the minimum, right?
Yeah.
Or assign a momentum, right? Whatever is easier. So you can either move it far away from the equilibrium, Or you can assign momentum. So set up the momentum at time 0 is not equal to 0, right? Good. How do you assign momentum to molecules?
It will be at the minimum position when there
Huh?
It will be at the minimum position when there is absolute temperature.
I think you're telling the right thing. Can you repeat it once again?
I'm just saying that it will be at the minimum position when it's at absolute temperature. So if you change, if we want to give it a momentum, that means we will move it from that minimum position. That means we will move it from the absolute temperature. That means from 0 Kelvin. Then it will be at different temperature and it will be at momentum.
Everyone agrees with Sudipta? I may say it with slightly different wording, but his idea is correct. Yes. So, what is the connection between momentum and temperature? Gage took PChem 2 in last year, statistical mechanics.
That's true.
Okay, so what's the connection between temperature and momentum?
I don't remember.
But, yes?
I'm not sure if this is right, but p squared over 2m is equal to 1/2 kpt.
Okay. So on the right, it is 1/2 kpt. Or kb is both on constant. What is on the left?
P squared over 2m.
Okay. And it is for one ion. And if you have n capital ions, you multiply, it is average, you put number of atoms here and there, right? Please, it is seen also here. Please lift hands if you've never seen this equation. Or give me like secret sign if you are hesitant.
Doesn't pop up and then
So which Kevin, teach us which course should we take to see this equation again?
I remember this is the equipartition theorem from statistical mechanics.
So some sort of thermodynamics or statistical mechanics.
Right.
Okay, so but it is correct. Things are simpler if you are not speaking in public for the record. Can you? Hello. How do you go?
Great, great.
So, what's the connection between momentum of atom and temperature in the room?
no pressure.
In physical sense or in interpersonal sense?
Isn't this the pressure volume equation? That kind of P, no, I'm not thinking it's right.
It was deceptional. Do not speak about pressure.
Okay. Okay.
Pressure is only one to me. If like an ion is moving, it has momentum. Is there a connection between
Degree of freedom, half degree.
Huh?
Degree of freedom.
Yeah, degree of freedom, or if it is like free atom in a gas. How does velocity depend on temperature?
It's not the PV equals nRT?
This PV equals nRT follows from these basic things, but very, very basic thing. How in PV nRT there is no momentum.
Right.
And letter P for momentum or V for velocity, not for volume.
Right, right.
So what's connection between momentum and temperature, or velocity and temperature? I know we need to rush through the material, but there is no reason to go quickly through if we miss the basics.
So your basic classical mechanics still applies, right? P is still equal to mv, right?
Yes.
Okay.
So the higher the temperature, the higher momentum, right?
Yeah.
Yeah.
So if you increase temperature, everything starts moving quicker. And if you want on the language of equations, temperature is nothing but kinetic energy.
Right.
So Kevin suggested us this equation: average momentum over two masses, 1/2 kT. Right. So if you need momentum, we need to take square root of kT. Okay? So please be ready to speak at things like this in public. It's like very basics. If there is a temperature, then ions start moving quicker. Okay? And if we are in the minimum of potential energy surface, but you do want to explore materials at non-zero temperature, it means we need to kick each ion and assign it a velocity. If it will have non-zero velocity, it will move towards turning point and then return and will start motion. If you start without momentum, if you start with P equals 0 and R equals R equilibrium, then there will be no motion. So we need to deviate system from the equilibrium. Okay, this little thing that it's okay. Once again, sending computer. Take off if you want. So this distributed material shows it on a little bit different system, but the idea, and by the way, Mary suggested that we all prepare little manuals. It is one of the manuals prepared by the students in the previous class, like 7 years ago. But there are templates, and we still have them both on the Photon and on Cori. So the idea that there are specific in-car assignments, in-car files that will lead system to away from equilibrium, to assign momentum, assign velocity to each ion. Okay, so it is specific. There is. I'm not sure if there is an analog in Gaussian. So it actually will put your system in motion. It will bring it to room temperature, or if you are ambitious, you can put like temperature when everything burns, like 10,000 Kelvin, but assigns as appropriate velocity to each ions. And there is a specific in-car. If you are curious about its content, the location is the same on all machines. I made sure that it is this way. So if you are on Photon or if you are on Core, do this command. And before you do everything, let me remind a little practical thing. For any job you are doing, try to organize independent specific directory. And if you do not feel that you have super good memory, you may keep a notebook with a list which directory for which. But it's get into untreatable mess very quickly. In like 2 days of intense computation will make your directories unreadable if you do not organize them. So make specific directory. If you are trying to do heat, call it, like give name for a model that you are treating and then give underscore heat or put temperature that if you want to heat a room or whatever. And then copy the template of the in card. And I will go through practical things and invite you to follow, but let's do things not in a blind way, but with little idea what we are doing.
So are we dealing with TI4 or TI32? Can we do it together?
I don't care what you're doing.
Okay.
I will suggest to do TI408, so little nanowire. I will be showing it, and if I will be also, if those who want, I will share the input files. And I hope to start it in like a couple of minutes, but. So, if you are looking through this in card, typically we don't. We believe that someone provided us good in cards. But if you're curious and look inside, you'll find that when you were doing optimization, there was a different number for this key, embryo. I think it was like 2 or 3, you will check. And there is a different value for parameter as mass. I think for optimization it was 3. And there is a new parameter and block. Just flash remember this word right now, and I will return to it again. So it is one of the parameters that you may want to modify. And your favorite 2 parameters that you're always checking the NSW number of steps and time step. So when we will be doing practical computation today here, we will reduce it substantially to like 10 or 30. Okay. So I am going to. Please make sure that you are on the Photon cluster. Yeah. What's the question?
I had a question.
Yes.
Oh.
On the document.
You do have it printed, right?
Yes.
Okay.
So here the under electronic relaxations, those parameters are for electronic relaxations, and those parameters are for ionic relaxation. It's like that. Like does it
Everything that is written under number symbol is just a comment.
Yeah.
Okay. Right now, do not change them. But the idea is that we neglect symmetry and we do some non-zero smearing to Fermi distribution. It is important for metals. If you are describing wide gap semiconductors, it doesn't matter. Okay.
Thank you, sir.
So I'm going to directory for the. What is this name? And make directory titanium 4. Periodic heat select whatever you. Right now we are doing just learning curve, and you do not need to literally stay with room temperature. In what follows, you better go to some crazy temperatures like 1000 or 2000, because then you immediately see some motions that may look fun.
Are we copying your files?
You can do your files, but nothing bad will happen.
Okay.
I'm just.
Oh, I see.
What is important? PV audit. So I do have a directory with 3 files. I'm not copying the in-car because all of us were practicing the same form of in-car up to now, which was not bad, but it was very narrow-minded. It was intentionally designed for optimizing geometry. Right now, we do not need optimization. Before, we were going from somewhere back to the minimum. Now we need to depart from the minimum. So to make an operation that is opposite to optimization. Okay? To a certain extent. You are welcome if, either to copy from my directory, and I will make a circle and do it, but if you have your own titanium dioxide nanowire, especially if you, in your homework, if you got like gap more than 3 electron volts, feel free to follow it. More postcard. So in the model that I'm going to pursue, I just replicated our original titanium dioxide nanowire from 1 unit cell to 2 unit cells, that it is a little longer. Right? So titanium 4, oxygen 8. And now it is periodic in Z direction. So the only practical step that I need is to before I do it, I'm going to cheat and teach you how to cheat. So we will run a little bit of WASP, we may run a little bit of WASP directly on a photon, which we shouldn't do generally. And if you see yourself that it takes too long time, then we can upload all files to Quarry and run stuff from there. But since time is very precious, so we already spent like 40 minutes and we need to finish soon. I'll show you the shortcut. So copy binary. So if you are creating your own Linux box and administrating it, there is a convention to have the binary subdirectory where you put all reasonable codes, because otherwise things get disorganized very quickly. And there is a template hit. You copy it into current directory and call it in car. Now let's look inside what is in this in car. So it is exactly the thing that was on this printed thing. And the parameter that we may want to change is temperature at the beginning and at the end. Did any of you operated programmable oven? One? David? Typical on the experimental questions, you answer positively. Like if you do inorganic synthesis, sometimes you need sintering, or you need to basically bake your samples. And there is a standard lab equipment, very inexpensive. It's just electric oven use thermostat and you program it where temperature ramps quickly. Because if you're showing the right thing. If you suddenly put your sample into preheated oven, it will crack. And if you're dealing with crystals, you do not want cracks, you need slowly ramp. We are not covering it right now, but it gives you opportunity. You can slowly ramp from beginning temperature to end temperature. But, we may, bless you. We may change it to bigger number because 300 Kelvin is always so boring. I'm putting it to 500, but you are welcome to put like 1,000 or 2,000 just to see what happens. And the other parameter that I want to change is NSW. Let's put maybe 40, because otherwise it will go a little too long. Right, quit. So, ls minus lt. There are 4 files. It is a ready. Well, I may double check that podcar is reasonable. Grep pbe podcar. So there is oxygen and titanium. And if I do head postcar, it also has oxygen and titanium. So binary was photo. So it is a replacement of. I noticed that many of you suffered of transferring files. There is a way to avoid it, but you'll see it's if it is like 10 atoms in the cell, it is okay. But as soon as you get more than 50, it will be pathetic. You run and it starts VASP calculations. So it is the thing that you will see in the output.
You just have 4 files in there, right?
Yes.
Okay.
So I'm going to make a circle and check if everyone is happy. Hopefully. And as it progresses, you'll see there are iterations for electronic iterations, and later on you will see ionic iterations. I'll just yeah. Cool. So M-I. I do here.
I may do the.
Oh, you already put it. Okay. Oh, you put 0 instead. If you would type O, it would not be very nice. One flight up to Europe, one flight up to the class directory.
That's another
and basically everything in the show.
I get that. You did this. You made this folder. Or is
Yes, it does exist in my subject.
That's what you just made.
Yes.
And so that's
Star means everything space, and here it means here. It also it has already copied a couple of output files because it has already started. Basically, you need only 4 input files.
I have a favor.
Let me attract attention and make a suggestion. So, although we didn't practice democracy yet for next presentation, who knows which subject you will present. So, if you have something you really like or something you really dislike and may need later, open PowerPoint and copy paste things that you are typing in command line into there. especially if it is something interesting. It's so much better to copy text rather than screenshot, because screenshot you later cannot copy it elsewhere. And if you copy text, you can later on take it from there and repeat it again.
This is what I have. I know I needed to go to 2 flights.
Yep.
I didn't do that, but if that would have been there, would that work? Or do I need Conca or something?
You better need
Oh, I need the flights. 2 flights.
Yes.
Yes.
There was no phone?
You know, I only did one.
No, there is no problem.
Anyway, I was just
Wait.
asking.
Oh, you want to practice? No. You want to practice? 2 flights.
Yeah, I was just saying all that other stuff that should have worked to get at least
And-
Conca.
So in order to see that you're doing the right thing, you always click tab. If it doesn't continue, it doesn't give you options, it means you already lost.
Okay.
Okay, please then do this. Okay. So
Okay.
you got it.
Perfect.
Okay. Copy, maybe it will be your subject for presentation.
Okay.
You will be able to, yeah. Good. And let's go to command line once again. So to launch the so if you do it, write things garbage in the screen, you go to next change then if you look garbage tables, you can do which
Just trying to look.
maybe it doesn't. So we have to go
This is molecular dynamics.
No. There are 2 steps. If you see here, first you need to heat, and then you need molecular dynamics. Heating is just bringing your system away from equilibrium. And when this job will be ready, then we go to the next step, which will be molecular dynamics.
Okay, go to the directory that you made.
Okay. And type.
This shortcut was important is old version, old format.
So CP, okay. Alright.
And then you go. You don't enter it. This is not this whole thing. So this is telling us copy. And so the first.
Well, I haven't tested that before, but that is being
4 0.
Yeah, that's what I mean.
Oh, I see what's allowed.
Space words.
Yeah.
Should I be in the can?
So on that.
Yeah, killing the phone.
Are you in camera or cameras? Oh yeah, he told us we're doing all this in full time.
Let me just.
Yeah, we don't know the entire directory path.
And this is through your account. So that's gonna like.
So you're in your way, yep, and then just make your.
One is your name, right? I mean, that's that. I was gonna put this step, but it's not gonna.
So if you keep trying to discuss it, you could change. Just start space.
That's not.
And in fact, you can see that it used to be another little cheating. Without any control, you'll start looking from the point where maybe it was all so it starts this fast. This is also okay. Now just see what that's computer. If you want to see what happens, you can go into the same clusters and go.
Okay, that's nice, that's nice.
So all you did was copy it.
That makes sense what I did.
Yeah. Now we have to again.
Right here is what you want.
Yeah, I did that copy stuff.
Okay, and then the next thing was to do, this part.
Okay, so I did everything that made my directory for you. I have my card, now I'm just trying to run fast.
Yeah.
I'm getting there.
Okay, I'll type. So do you follow this stuff? literally because it was done for given plastic.
Grace, I found this train.
Oh, right here. This one. I need to do greater than. He, so my screen keeps moving, and he says, if you do this, it doesn't move.
Look here.
And so vast photon, yeah.
Look here, you got it.
Yep, so previous. No, you're good.
So that's your.
Our numbers now.
Yes.
One.
500. All right, thanks.
So,
Just like closing this screen. Everything, like skills, have files.
This is lab9.
Last semester we did it. This semester we're supposed to keep 97. Yeah.
Is it running? Yeah. Okay, thanks for. Yes?
Okay, so I was a little late on the details, but I did transfer the files here. That's where I'm at right now. So what did you change in school?
I want to change something. Cheese.
Oh, so the TEB, okay, all right. So you wanted that at 500, and both of those need to be changed then?
You can go wild.
Oh, so you do a range, like one is 500 and one is 1500, or does it matter?
Do you practice programming always? If you use fragile crystals,
Okay.
fragile crystal, precious fragile crystal. And then preheated Celsius, it will crack.
Yep.
And some equipments will run
Okay, okay.
1 degree or 1 degree.
Oh, so this is a range?
Yes.
This is, okay, so you're starting with,
Yeah.
okay.
Okay. And here, 40 is a little short, it's just for education purposes. In fact, one needs like 300 if we are, if you have more.
Oh, I see, like beginning, end, I see the words in there now.
So,
Okay, that's what you did too, okay.
and there is more like to show that you do not wait on the queue.
Okay.
But on the other hand, you see how slow it is for this pathetic 10 atoms. It takes like half an hour. If you do it in minutes, maybe you will wait for half an hour, but then everything will be done in 1 minute.
Okay, okay. Question, are you free after class? I'm having trouble spelling D&D. Okay. I want to make sure I have it on my system. Or will you show us today, if there's time?
Well, I do not have admin password for here, so I'm not going to install anything.
Oh,
on
okay,
my
gotcha,
public
gotcha.
computer. I requested that university installs it here, but they're not always responsive to. Let's check. Maybe they did find it.
Oh, I calculated the density. It was just a little bit higher. So, very good.
So they didn't. I asked her, they didn't.
Oh.
So we will be on our own. So I don't know how we are pursuing very ambitious plans, and time is against us. So it shows.
Check. Good.
It's not the whole story. I'm going to focus back on this central. So if things went favorable, we are moved from the equilibrium away to the equilibrium, and now we should have momentum. Like if you look for the quant card, did I look off? No, good. If I look at the quant card, you will see a little difference from what you saw during the optimization. I don't know if you were looking inside the files, and you should have the same thing very soon, right? Since your job is running. So there is a segment for positions of ions in fractional coordinates. And here you see another section. It was also here before, but it was all zeros, right? So now those are values of momentum or velocity of each ion. So these are three Cartesian projections of the momentum along x, y, and z for first ion. Those are projections of momentum x, y, and z for the second one, right? So it is the actual information where temperature is stored, right? And if you are, if your head is like a computer, you can avoid this step of heating and just assign some random velocities to all ions and all components and believe that it is a good initial condition. But it's too many numbers, therefore there is automatic procedure that makes some random procedure to assign random direction velocities to each ion. It's like putting your model on a stove, right? So these numbers are main outcome. Next computational step will be running specific in-car for molecular dynamics. But before we go to refocus. Okay. Before we go to this step, I may want to check that the numbers in this that our intermediate geometry and velocities stored in the concar file are reasonable, right? Some of you were declaring or complaining that during optimization some pieces of your molecule teared apart, right?
Yep.
It may happen here. Sometimes we intentionally desire it if you do like combustion, but we just need to know what is going on. So when you are, let's do more OS Z car. And please give me signs if your job has completed. If you still running? Anyone completed? One? And Kevin, right?
I'm checking.
It is done.
Oh, okay.
Yeah. And Kevin did the same job on the Quarry instead of Photon, so it was like 100 times quicker for him. You know, if you do not hate uploading files, you take all these 4 files, upload to your subdirectory in Quarry, and submit a job. Or there is a trick, there is another. Next second, it will be not a trick anymore because only 2 persons in class knew about it, Mary and Kevin. There is another server on NERSC called Edison, and it is much less occupied by users, so jobs went into computation substantially quicker.
So Edison is a different server than Corey?
Yes, it's like in different room. They share the same space disk directory. They share the same file server, but computationally those are independent.
So all you did for me was run the same job on Edison as you did with Corey?
Yeah, in different directories.
Okay.
You did set up competition, who is quicker.
All right.
Yes?
So we're doing temperature right now, and we talked about the relationship between the temperature and our
Momentum, velocity, yes.
But I do have a question. Are we
Yes.
going to talk about pressure?
Sure.
Is that like easy to incorporate or is it difficult?
Just a second.
Okay.
Grab, press, out car. So it shows pressure to your model in kilobars.
Okay. So
And negative means that it doesn't have enough internal pressure. It is being pressed from outside. If you have a crystal without strain and pressure, zero is good.
yeah. Okay.
Positive means that your system pushes walls of the box outside. Negative means there is a pressure inside the box. Okay?
Okay.
So it's super simple. And there is a keyword to optimize your cell in such way that pressure will go to zero. So you can, and this is the way how to squeeze fluffy polymers into a solid thing. So if you look into more OSI-car, it will show the thing that you were observing on your screens, right? And if you look through, I know it was not in, no one in the class had intention to read through this boarding file while signing for the course. And it is not demanded, but sometimes it is useful to look through this technical information. So if you look into the file OSI-car, when you do optimization, it shows F equals, free energy equals. And it goes towards this number, well, not here. When you do optimization, F equals, and the number goes lower and lower to like -1000 or negative whatever, because it comes to the equilibrium minimum. When you're doing temperature ranking and molecular dynamics, it shows, so those are numbers of ionic steps. Each time ions are moved, it recomputes either total energy if we are optimization or temperature. And here it shows temperature in Kelvin. So we start with 500, and next time it's 0. Then 0 again, 0 and 1, and then 500 again. So we requested, here is the little wonder, surprise, puzzle, and intellectual challenge. When I will finish speaking, your jobs will be done. So you request that your system will move each ion, will assign velocities to each ion corresponding to certain temperature. We request it to be 500 Kelvin, right? And next femtosecond, we set up, or next half femtosecond, whatever put you set, it goes to 0, right? And then if you go further, you set up it, then we attempt to set it at 500, and then it still goes lower, right? So the system resists to our attempt to raise the temperature. So do you have an idea what is going on, what's the physical reason for it, and how to fight this resistance? A system resists to heat.
Wouldn't the heating cause a problem with, say, too much entropy, and so we want to reduce the disorder?
This mechanism can be launched, but it is too far. There is something much more basic.
Okay.
Like, how long does it take to cook the soup? A soup. Can you cook a soup in a femtosecond?
Yeah.
With like laser ignition?
Probably.
Whatever you want.
Probably not. Some synthetic reactions in wet labs happen over substantial time, unless it is femtosecond reactions. So some of them take hours. It's because there are twists of dihedral angles. There is time until reactants float each other and come at different angles. So things cannot be done quickly, right? And we want system to be instantaneously heated up to 500 Kelvin.
Without break, right? Would it
Huh?
cause a problem if we did that?
Well, there are no problems. It is just objective reality that we find successful. But I want to attract your attention to this challenge. And some people are bored with obstacles, and some are opposite, like intellectual challenges more than other things. And some like music. So, what are we doing on this diagram?
Moving the relaxed electron up and moving
Up. You are absolutely right. We are moving it up. If we assign velocities, we do not change anything to positions, right? So when you assign velocities, you do not change positions. You just kick each ion and assign it in momentum, which means it's still at the equilibrium position, but it is here. And then you let it go, and how do you graphically define portions between total energy, kinetic energy, and potential energy? I don't have energy to set up it as a trick. I will just introduce it if you never heard it. Kevin? Do you have an idea what I'm going to draw?
it's a wave. You're drawing.
No, portions of, it's classical mechanics. Total energy, kinetic energy, and potential energy, you can call it T and U, in graphical form for the harmonic oscillator. So at each step of trajectory, this proportion will be different. So this top line is total energy. The height here is, so this one is total. E total. This one will be E potential, or U of R. And then the rest, difference between them, will be kinetic, which we will call this letter T. So adding together potential plus kinetic will give you the total. But depending on where we are on this potential landscape, if you are right above, it will be, everything will be kinetic. If you move to the turning point, you will have zero kinetic, everything will be potential. Right? And what we see in the screen, when it goes from 500 back to zero, system quickly reaches turning point and all kinetic energy becomes zero. And the only way to find it is to reassign momentum again and again and wait until it equilibrates. So in order to speak about temperature, we need thermal equilibrium.
So you keep in the kinetic motion.
We need to add kinetic motion again and again so that it equilibrates, and in average, kinetic energy and potential energy per degree of freedom will come to equilibrium values.
What's on the y and x axis again?
Yeah.
It is position and energy. Right?
Right.
So
What I'm going to do, I'm going to look at this T equals things. Grab T equals OZCAR. Better. And I may forward it to the new file. I can call it TT. No plot. So the temperature is stored in the column 1, 2, 3, column number 3. So I may want to set term dump and plot TT using using 3, these lines. If these abbreviations sound crazy for you, ask Sudipta. He's our guru in using of GNU plugin. There is a way to make a nice graphical file, but right now we need just general concept. So this is steps how we go through the dynamics heating, and this is temperature in kelvins. So we start at 500, and then due to quick equilibration, quick transfer of potential of kinetic energy into potential, temperature is dropped to 0. Then we reset, we kick it again to have temperature 500, and then it drops, equilibrates. Then we set it again, and again, and if you wait long enough, it will equilibrate to the desired temperature. Okay, I think it is time to make a tour around and make sure that everyone is on the same page.
My stuff's still running.
If your human patience is expiring, well, if our time for the class is expiring, and we still need to do orbitals in addition to molecular dynamics.
Okay.
Right? So try to upload the input files to like Corey or Edison and submit it there.
SCP?
Oh yes, your
No.
favorite command of me. Show me.
Oh, no, you just killed it so earlier.
No. What? Okay, let's assume that let's do the same things that you did there. I don't know. What would see this? I'll visit you again in a second. So we launch more actual programs. All right.
Yep.
Yes. Well, it is done. I didn't have to transfer it.
If you are successful in doing it, just help each other.
You guys done? No? Yes, no?
Oh, you didn't put it before.
Yours is done, you just had to slow down.
Oh, okay.
So I have more
This is what he told me when we made it all. I'll just rats. But you gotta control it.
Huh? You're doing different systems. Before I continue the tour, so the larger the system, the quicker equilibration happens. If you have like small molecule like methane, it will never equilibrate. Those theories for statistics and thermodynamics work for large number of atoms. And from this point of view, it is more beneficial to operate larger systems, like thousands of atoms.
I learned the hard way, so yes.
Oh.
Yeah, but keeps breaking set term. This one might be.
And then, block CT for.
If you continue forward, you will.
Yeah, you grab a little bit.
Before I approach you, let me show something. Notice that the temperature is, velocities are rescaled. Velocities are rescaled each for femtoseconds, or each 4 steps, right? When we wait, and then set it back to 500. When we wait, set to 500. Where this parameter comes from? Oops. More in car. So the parameter n block tells how frequent the system is being kicked. Means like how intense it interacts with the thermostat. So each 4 steps, it is rescaled.
Is there a benefit to choosing 4, or could you choose any number?
If you are unlimited in the resources, larger value would be more beneficial.
Okay.
Okay, good. So closer to the because you started with some advanced forward, you came to this reaching the place. Good. Very good. Very good. Do you install LinkedIn? Okay, good. We will use it today. Sure. Did you make this image?
No, I had. I've been using PC all the next to my work.
Okay, let me show you this stuff.
What's the Aussie card thing?
Where is it?
What does it do?
It gives you total. It gives you energies, total energy. The heats and the energies of your system. Total energy. That's all I know. Spark.
All right.
If you open it and you go all the way down, the last energy you see is going to be the stable one. So when you open it.
Well, he didn't let mine run all the way. Killed mine, really.
Oh, I mean, just yeah.
Are you saying the energy's part of the energy's like here?
The total energy of your system. It's going to be at the very bottom line.
Yeah, if it were to have been able to run. Okay.
Yeah. You'll have different iterations too. You just have to go down.
Did you got this teeth? Nice. Did you put this constellation? Optimization of German. So, right, we didn't start molecular dynamics yet. We are doing just heating. Right now we are covering just technical tools. When we do code, we need to write such small time step. You cannot set up big time step. Did you get this short test?
I didn't see your no. I
Okay,
didn't.
okay, I will be with you. I just answer Anna's brought up interesting question. So, correct me if I misunderstood. He was asking how can we use so small time step for t equals 0.5 or 1? Because a lot of processes in nature happen in the longer time scale. If we need to describe longer processes, we just need NSW equals very huge number, many steps. But you cannot many steps, but the size of the step cannot be made bigger than like maximum maybe 2 femtoseconds. If we go too quickly, we can very easily jump to a region of dissociation or explosion or instability, and the system will just explode. So if you are hating VASP and practicing hyperchem molecular dynamics, you do have a parameter for time step. And you will see immediately if you play and set it up bigger than 1 femtosecond, like 10 femtoseconds, your system, even with classical force field, it will start explode crazily. So there are limitations. We are using as big as possible, maybe a little smaller. Like, if there are hydrogens, the period of oscillation of CH bond is like 20 femtoseconds. And you need to do like at least 10 times smaller than period of oscillations, otherwise it will explode. If you have only heavy atoms like cesium and bromine, yeah, you can increase 14 to 5 and there will be no penalty for this. But for organics, we are bound to small time steps. So if you are done with this heating and you are bored, open new directory, call it MD, copy everything from heating to MD, and then follow this print out. So you need to copy specific in carbon and then run MD. I will show it, demonstrate, and then make a circle in very shortly.
This has been too long for me. I tried looking at this. We're in the computer lab.
Set. Done. We are going very old fashioned.
Yeah, I don't remember that set term done. It didn't sound familiar to me.
And then we don't have this one. So we need to parse this T equals. So rep T equals. And you don't want it to screen, you want to forward it to the file that we need. Okay.
Right, that's right. Okay.
And then we need to what? This set that term done. And then okay?
Okay.
This could be a signature of exploding. See, it goes higher and
Yeah.
higher. Right now we are on a learning curve. It's nothing but it could be only fun, but so originally, ideally, it should equilibrate. If temperature goes without control to high values, it means something is exploding, right?
My crystal broke.
And by the way, we will discuss projects very soon. It's one of the possible area of projects, like set up nitroglycerin or TNT molecules in your simulation cell and apply shock wave and see what happens on a molecular level. It's very, very possible. It's good project. Okay. So, what I'm going to do, I am creating a new directory, main directory, titanium, titanium 4, periodic, MD, not for medical doctor, but for molecular dynamics. 500. Okay. Now I'm copying everything. Well, I can be old-fashioned and meticulous and copy only those files that I need, like contcar, podcar, postcar, but I better copy everything because I'm so lazy and I don't want to bother. Then I'm going to a new directory. Again, there is nothing wrong to run jobs in the same directory, but you will suffer if you run multiple jobs in the same directory. You will suffer very, very soon. So it's not a big effort to set up special directory for each job, and you will appreciate it later. So I'm creating a new directory, copying everything there, and I'm going myself there. Now, there I'm copying contcar into postcar, because I want the output of my previous step to serve as an input for the next step. Now, I also need to remove incar, because old incar is not good anymore. For molecular dynamics, I need different incar, so I'm removing incar. And now I'm copying from the binary slash incar. There should be incar-md, copying it into here and call it incar. Let's look into this word stuff. We covered it. Contcar file does have the velocities, and some of them are negative, just interesting. Good. And we are doing this step, copying the template of incar locally. And here is how it looks like. So so the only thing you may want to change here is so in this incar, with the settings of hydron and SMAS, beginning and end will not change anything. It will affect only electronic temperature and Fermi distribution. The temperature is already the ionic temperature. Is determined by your postcar file, but you may want to change NSW, because if you put it too long, it is cool. For projects you need to run long molecular dynamics, but here our human patience will expire. Okay, we'll go back. More incar. So I do want to change this NSW 1000 to maybe like 30 or 40.
I mean, if we're
I will make a circle, but before, if you, so.
Well, yeah, I mean,
Summary, creating new directory,
Yep.
copying output from previous directory to new directory,
Yep.
removing incar, copying into new directory, new template of incar, and then make an adjustment to NSW, nothing else. So if I request it to be 1000, it will run for maybe until morning or until next morning. And we need just to see how it works. So put like 30 or 40. Okay, 40. Very ambitious. And now I'm doing the same. just bin wasp photo. Okay.
I'm stuck.
That's normal. You guys are my champions. When in my career, I wanted to do only pen and paper theory, but my postdoctoral advisor twisted my arms to do computations. I was resisting, but my learning curve to learn how to use WASP took 3 years. You are doing it in 1.5 months, so you are about 30 times smarter than I.
No.
You do not need to copy from my drawing.
Well,
I don't mind, but you have your own data, right?
Well, my dad is pretty long.
So, with one for you. And then you have your own taking something.
I know.
You just copy everything.
Yeah.
Here's the other. Good? Now, most important, copy on card and it was never forget. It's the most important step in all computers.
So, input to the output, so.
Output to input. Output of previous step as an input to input step. It's like industrial assembly line. Your sample exits one operation and enters another. Or in the lab, you pass the sample from one table to another one. Okay, then remove out input. You are so there is a derivative you see the upper level in circumstances. If you need the one that dash so name of the in-car should be always in-car. If you name differently things
So put it the in-car that is in one and over.
yes. And now you see it was different. You need to change. Yeah, 30 will be easier because people number to explain escape or space. You'll be able to do it.
Oh, yeah.
Yeah, sure. So, you may probably got substantial amount of feelings of irritation against either instructor or WASP or Linux command line. So Linux command line is very unforgiving. It's it will not guess what you think and will require literal file names, literal spaces or absence of spaces. For example, it is literal to the file names, to the upper or lowercase. We all are humans. It is not possible to memorize all this stuff. But if you let me speak about the operation we recently did with this copy of the in-car. So look here, it is lowercase md. And if you do not know what it is, you just type until here and type tabular, tab. And if you prompt, it will show contents of this directory and you can choose from. Okay? And if you choose from, you will see that there is no uppercase md, there is lowercase. So it is whatever we as humans decide to give names to our files, but then we need to follow it.
shows everything that is there. Tab space. In tab and tab and dash. Then you do tab lowercase and pivot here, or you can actually hold in. Okay. 1,000 is too much for.
Mead, I'm doing this, I'm going backwards.
We all
I know exactly what's
I need
wrong.
to copy one code.
Excellent.
Run it once again.
So, so if your human patience is not so developed, you can just upload the files to Ori or Edison and have it completed in 30 seconds.
You didn't.
Oh, no.
By the way, did you use your button anytime? Okay.
Yes! No, oh, no, it's okay, it's okay.
Since you are on a server, you can. Okay. Is everyone using this? No, everyone is using phone. Okay. Okay. So if you would be on a smaller server, you would do this in dimensions. One is only one row. Okay. And then it goes to. That's going to be. Alright, if your system is you can figure out the place that you will pay for it knows additional. Just put it So how do you get from the previous week back to this week?
this empty yet?
Yeah.
Yeah.
And you can.
Yes. Sorry, I had to think about that.
Yeah, no.
Oh,
It's a little swollen, but it is less confusing. Oh, you need this one. So now you just run. If you do not want to run forever, you need to move like it doesn't steps will not fit. Does it go?
Yes.
Are you able to run? Good.
Yes, it is. It is. It looks like it's.
Okay. Yeah, it's not really. So it will take a couple of minutes to see how the calculation is completed, and you can also do the same analysis of the Aussie car. Make this grep t equals Aussie car and analyze so if there are no chemical reactions, the molecular dynamics temperature should just fluctuate near the value that you did set up. If there are endothermic reactions, then overall energy may drop. If it is exothermic, like combustion or explosion, it will go up. And sometimes things may look like exothermic reactions or like combustion just if system is numerically unstable. So when it's in order to check that it is not instability but actual reaction, one may set up smaller step, time step and repeat. Here is one of the so here's the command that everyone is invited to practice. It is just wait until your dynamics is done, and there is no way to complete the course without this command. So, and it will be a big pleasure for all of you, I promise. I'll tell you in a minute. On the photon, the path to this command is very short. If you are on Cori or Edison, the path is a little longer, and I'll probably show it to you right now, just that you know. So this command creates, so I did ls minus lt, create a file named movie.xyz. So if you look more movie.xyz, it creates xyz coordinates. So this system has 12 atoms, but it shows once, then again. So it creates slices of the molecular dynamics. As many steps in your molecular dynamics, as many slices. Okay? So the quickest way to visualize what you've got is JMOL. Here's our model. And you see that something is happening. Bond, maybe it's breaking, maybe it's just oscillations of higher intensity, of higher amplitude. But though this is, let me stop it. Increase a little. And you see the alignments. It is what we discussed for this titanium oxide display. So each titanium is tetrahedral coordinated to oxygens, and the angles of this oxygen planes changing by 90 degrees. Extras, animate, and then hit play. So right now, this is there is not much scientific information. It's more a learning curve, right? But for the projects, we all will run much longer dynamics for bigger systems where something interesting will happen. Okay? And of course, we can put these things on recording and then extract little portion from YouTube, but it is very inefficient. The best way is to use specific software for creating movies that one can insert into PowerPoint. And I will make sure that first everyone can do this little JMO visualization, but then the goal is to create a movie. There are several ways to do it, but the quickest one, most optimal, is with VMD. So everyone is in VMD will run this thing and store it on the file in the MPG file or .avi file that you can insert into PowerPoint and present. So please consider to install VMD on your equipment. So I'm going to walk around and see if, give me a sign if your molecular dynamics is done. 1, 2.
Yeah.
Oh, it is done. Good. So, let me deep fingers into your so VT, and then let me put in right? Okay.
Yeah, but at that heat, and then one thermodynamics is just trying to find the equilibrium.
So we did run 2 jobs: first heating and second molecular dynamics. You cannot do adequate molecular dynamics from heating. It is just heating is reasonable procedure to bring system away from equilibrium. And molecular dynamics with microcanonical ensemble keeps the energy constant, total energy constant, and let system explore phase space and browse through different configurations. So it is what happening for in real life for like reactions or in gases or liquids.
So it wants the higher energy state just to keep searching for what the lowest is.
Wait. No searching. Just literal modeling what is happening in nature. Okay. So heating is a service procedure, just auxiliary, and molecular dynamics is actually watching the nature. Good.
Yep.
By the way, JMO is free software that you can also download to your laptops and run this stuff locally. Because when I think the Photon server will survive if all of us will run this JMO, but it will start rotating the fan with higher speed and heating a little more. Okay. It's not in here. It is in the other area on my.
That area of my computer.
Yeah, this is a check.
So if you are just quick, if you want to practice this x.car2xyz on Quarry, module which module show WASP, and it shows everything related to WASP. So this you may recognize this VTST scripts. So this long path includes the so x.2xyz is stored there. Okay, and if you are on Edison, the path is slightly different. But when you type module show WASP, it will show you all directories related to this software. Well, right now it complains because I run it in the directory where there is no WASP output. This font is large enough? You want larger font? I knew how to do it before. Terminal. Can you do just settings, configuration. I'm just using it as display for increasing. Okay, let me make a circle and make sure that everyone runs the visual stuff.
Yeah.
How many steps do you modify or you default 1000?
I'm on.
Oh, okay, so and if you have energy, you may try to run the same things all over the space. I will not like supervise it now because time is limited. Were you able to do the
No. What is
You're right. I have a sword.
But as soon as you have this movie with XYZ, you can download it to visualize this different circuit. VMD is the best, but I don't have the answer. You do? Yeah. Well, try to download this movie file to open this. So you did. Congratulations. Yes. Now you can instruct him. He's your teacher. Next 5 minutes. How many steps do you want? 40?
I don't remember.
Oh. Oh. Okay.
I
If you didn't modify by default, it was 1,000, so you probably don't have patience to wait. But you can go into different directory and use other data, right? Or you can visualize intermediate data.
Okay.
Little announcement. The x.2xyz command will work even if your data is incomplete, if your job is still running, right? So you can log into same directory from different terminal, apply this command and see what is going on. Okay. By the way, if you do optimization of some complicated thing, you can run it as well and see if your optimization goes into the right direction. And it is very much recommended for any practical work to check that your system is not broken. While you're doing optimization, you can practice x.2xyz command and visualize steps of optimization.
How
You
do
don't.
How do I kill it then if I want to stop it?
Oh, you don't need to kill it.
Okay.
Just approach it from here. GSU.
Compare it to your
Yeah, it would be so it'd be an instant, yes.
So
I don't know why we understand. I just
something.
So it's falling apart too.
Well, it could be large amplitude oscillations and it may come back. Notice that this 40 femtoseconds is nothing. It's it's a long time only for hydrogen vibrations. For most processes, it's like as Anna's noticed. So typical reactions happening on the longer time scale.
So this may not fall apart. It may come back together. Or
It may
okay.
if you would simulate it for longer.
It's right here.
I just don't have.
So I still have time to download VMD either like today or tomorrow.
So everyone got movies, right? So maybe do you have Steam for another little skill? Let's do it. I'll show it.
Okay.
I'll show it. So orbitals that you all like, right?
Yes.
So I'm going to photon, and I'm going to the directory where I didn't started any modifications, no motion, no heating. And I'm checking that there is a wave car. You know that wave car is needed, right? So, I am creating, and I'll explain why. Make directory periodic, show them periodic orbitals. And again, one needs only postcar, podcar, key points, and wave car, but I'm copying everything there. I just do not want to make a wait. Maybe all are not super fresh, especially me. Make directory, copy everything to this directory. Yes, that's good. Now I'm going to the new directories where we will be practicing orbitals. So, copying pont car into postcar, I'm doing always in case there was some optimization, and then doing a couple of tests. So, grep NBA out card. NBA is not National Basketball Association, it's number of bands, right? I can also tail minus 200 out card. If I would create energy pop file, I would look there, but I didn't. So I look on the orbitals and I know that the HOMO is 32 in this model. And the gap is, okay, reasonable. So I need orbitals, and the energies, the range of energies where I need is from like maybe -8 to -2 or -1. So I need these orbitals and this range of energies. So interval of energies is the only important thing I need. Now I am removing in car, and I'm doing the same operation. Copy binary repository for in-cars, in-car, and I'm looking for something that looks like orbital or partial charge density. PC, not personal computer, partial charge. Here, in-car, VI in-car. So, this is, remember, in the Gaussian, you do have check, form check, and then cube gen, right?
Yes.
So your orbitals all are stored in check. Here, all orbitals are already stored in wavecar, but we need to extract them for visualization. And instead of form check and cube gen, we will run VASP software again, but with a specific in-car. So we need to modify 2 lines. Energy interval, so we need to put interval of energies in which we need the orbitals from -8 to 0, let's say. And we need to put right number of bands. What was the number of bands? NBA? 39? No, 32 is HOMO. Let's make a bet and check. 39. Okay. So once again, more in car. I changed the energy interval and changed the n bands. And there are specific keywords that will correspond for the one of the partial density equals true and separate bands equal true. Those are that VASP will not optimize or run any dynamics. It will just read wavecar and convert attention to band. and convert the orbitals from k-space, from expansion coefficients in front of plane waves, into space distributions. So what I'm doing, I'm just running the WASP once again. WASP photon, and then it tells wavecar file was read successfully, and then it tells band. So they use different language. Instead of orbital, they call them bands because it will be related to solid state. So orbital number 26, and then when it reports, all orbitals are stored. I will make a circle and make sure that everyone has it. So ls minus lt, you see there are new files called par charge. So those are orbitals. And if you do have VMD, it will directly open these files and visualize them with nicer clouds. If you do not have VMD, by the way, it is installed on the photon, but it may work with delays. If you do not have VMD, there is a VT CHG cube or charge. Three. Oxygen. What's the number of oxygen? 6?
Are you checking about
In
the
oxygen in periodic table.
just 8.
8? Okay, what's number of titanium in periodic table?
More than that.
35.
No.
No.
How much?
I want to say 23, but I'm not positive.
I know that
22.
22. Very close. Okay, great points. And now this command, we need this charge to cube only if you do not have access to VMD. And then ls minus lt. Okay. It creates a cube file that is readable by WASP view, Gauss view. It has this model, and then same as we did before, we do so HOMO orbital occupied has charge density of p type only on oxygens, right? Okay, let me make a circle and make sure that everyone is on the same page.
All I've done is made that folder things on there. So I apologize. Yeah.
I can type in even if I can speak.
Push escape.
Oh, it's
Push semicolon.
So, what's minus dash PC. Space.
Alright.
Now the number of bits. If it will be different than the one in the reference system, then it will panic at the same system. And here the interval of instead of giving specific number for bits, you just energy from -8 to 0 in this condition. That is the interesting.
-8.
Or -8%.
You need to do more.
It is. It's really proceeding by only saving resources. You can probably prove the internet how to do it. Only from here how to do that. Oh, should I bring back commands? And if you are doing the same thing, try to maybe do next orbital, number 33, for Luma. It will be much more spectacular. It is expected to be d orbitals. Which area should I show? Which?
Yeah, keep going. I think.
This one, energy interval? Or higher up?
Higher.
What if we've already lost steam?
It is the last thing for today.
Okay, okay.
I don't know how I was managing in previous years. We covered like more material in shorter time, but maybe I'm losing steam resilience. Gauge enough or?
A little bit higher.
Let me come. We'll do it together much quicker than I'm browsing through. Let's just see
How far did you listen
Queenie, I just need some real sleep.
This whole week, I've had 4 hours of sleep average every day.
That's not good. That's not good.
And so this was gonna happen on Sunday. I have to leave.
Why? Oh, for their trip.
So Saturday I'm gonna crash before I leave.
in this case?
I like to shut down. Just waiting for it to shut it down.
Are you sure that that's?
Do you rate this?
No, you don't. I got the report. You're in this folder.
Reviewing them in Gauss view?
No,
So I got the file
I
set
forgot
up.
what we're using. We're using something different.
June?
No, maybe we were. I don't know. I don't. I'm not even really here right now, so trust me.
Okay, I'll let you be.
Well, it skips.
You need to do a special command to copy
Maybe not use the web.
Okay, well, you were going the next step. I was PC forensics my
That's okay, no problem.
that simply means that you're going to make help you across Yes.
Did you make your recipes? Oh, okay. I have a left. It's like the same process, copying
You need to, and then to the right number. You need to put the right number. Not the comment. The action. It doesn't, the comment doesn't matter. Now it does, because
Or you're one forever.
Perfect.
Well, I'm sure
Did you try to do orbitals? Let me know. That's correct. Yes, you can do, you could choose, you can take this one, and then you can do both this stuff. So you just kind of
Yeah.
big headache. What would you call that? Yeah, that's a little bit.
You know, it's fairly new. Everyone hates it. Speed, they're getting change, game industry. They've been making this step slowly, right?
Will they use the wall on those things? I don't even know what that's.
Well, they have some.
I'm sorry, I just. So this is where I was.
Who? Yep.
The cubes.
Except it's not being published right now. For obvious reasons. Division 2 slide picture.
Everything? Oh.
I always wanted to try out those.
Changing what is basketball. Copying template. Directly with templates in our PC here and name it. So the that should be
Yeah, I do that.
Almost like I from I road. And here is the it will be different for every system, but here we will check this for minus because you include really quick. So the two is home, so the two is done. So if you have VMD, you just open it.
No, I don't
download
have
it.
it. It's yeah.
Not today, but
Yeah, well, we'll just.
So V T church to view. So our church is the names of all of those. And now it asks if our church is the atomic numbers for oxygen.
Oh, that was 8.
8, okay. And for titanium.
It's 22.
And now it's minus 19. So there are those per church and this Q. So you do
Okay, so it wasn't yesterday.
you do same things in
My calculation is done. Now, I want to
visualize the thing. And then there it goes.
So they
Okay.
when deep work comes down,
Yep.
Okay.
Okay, I have to go.
Yeah, that's okay.
Okay.
Who was able to show orbitals?
Was that JMO or was it Ghost?
Ghost view. Did you go to the orbitals? Okay, one. So, and what? Two less. So, no, do not go there. You didn't convert files. All you do is stop and so, the command to convert orbitals from VASC format to Gaussian format are charge to cube, chg to cube dot cube. They are located in the same directory where the command that we use to generate movie file, btst2 / char chg to cube. I will make a round and show it. Maybe I can show it right here.
All right, see you tomorrow.
So here's the command. Then it asks what is hashtag modifier units, part charge, atomic numbers for oxygen 8, then you are getting U file. And when your goes use open, does it say open?
No, I close. Just the visualization of the orbitals, and
Yes.
then we still have to visualize the MD with that.
MD.
I know the molecular dynamic video and this. Are you? I know what the.
Those are two different skills. They are
Yep.
disconnected.
Yep.
I'm not bringing in. There is internal connection between everything, but right now we do not care. Okay? As soon as you
Yep.
record how to do it, you are welcome to the party.
That's okay.
And then because The version of Wasp installed on the photon is the obsolete version number 4 that uses slightly different format of the postcard.
I don't think I actually created
Okay. Just reads with card and the rest perfect. I was not very okay.
Okay, my files just got finished.
Super.
Screen freeze.
Yeah, dude. Do you guys need a ride?
Did you drive?
Yeah.
Are you going back to the lab?
Well, I can bring you.
I'll keep in my backpack.
Oh.
I don't want to carry to the gym.
I got you.
consult with each other.
How do you know which part should?
It's number one. You have a good instructor?
Yeah.
Or you don't trust them?
Oh, no, we trust that. There is
Not a problem. We need over the numbers of the more. Just per church. It's going to be oxygen taking oxygen sleep. Based on the university. Yes. Okay, I think it is more than enough for today. Thank you for your patience. I'll stay here to answer maybe some minor questions, but it is more than enough for one night. So if do not stop. Keep going on your plans. If you do have access to VMD, this visualization would go more pleasant. The only thing that left and will be presented by a postdoc next Wednesday, whenever you're here, anions, cations, and spin polarized stuff. And keep going.
How long did it take you to know all of this?
3 years. Because I was very bad postdoc. I was resisting what my advisor was requesting from me.
Yeah, why were you against computation?
Huh?
Why were you against computation?
Because I thought that it is a more run ahead job. That only theory explained papers or something.
I've noticed.
Wait.
Oh yeah, what is this? Yeah.
Are true. Oh, you do have VMD. Then you do videos here.
Yeah. So how can I edit from here again? Like bigger from here?
Oh. Oh yes, much better. So
Sir, iso substance.
I know the tortilla you did was the meat. Well, Dr. McKillen?
Well, PhD candidate Erickson?
Yeah, we will, see you tomorrow.
It would be my great pleasure.
Good. We'll be there. We're gonna be in that awesome office, or the
I think we will be as usual in this,
QBB, or email.
yes, you know.
Oh, yeah.
Yeah, as far as I know, you don't need to talk to Greg.